Hello dear students, welcome to the practical session of fluid mechanics and hydraulic machines. So today we are going to discuss Orifice Meter. Myself Mihir Mistry from LJ Institute of Engineering and Technology. Now our aim is to determine the coefficient of discharge for Orifice Meter. So let's understand the Orifice Meter first. So the basic understanding is very simple. As you can see, orifice is nothing but a small plate, having small hole diameter, right, through itself. So that is known as orifice. So what you will do? You will obstruct the flow of fluid by inserting orifice inside the flow path, right? So here you can see this is the orifice plate inserted over here, highlighted by nearly yellow color, and you can see the blue color is representing the flow. So the flow will be obstructed, right? So now what we will do? Here two sections are important. This particular section right now, so this will be called as vena contracta. It is nothing but the area or the point at which minimum cross section of flow will occur. So corresponding to that particular vena contracta, we will attach a pressure tank through which you can attach a tube connected to the U-tube manometer. Okay, so this is nothing but the connection of right limb of U-tube manometer, and the left side will be connected to the pipe section. Okay, so that is the left limb of the U-tube manometer. So you can have the difference between these two, right? Because here the diameter is larger, that means cross section area is larger, that means pressure will be higher. And at here the diameter is smaller for the flow, that means cross section area of the flow is smaller, that means pressure will be low and the velocity will be high at vena contracta, right? So that is why you can observe and appreciate here that the manometric fluid will shift like this, right? That means in the left limb the fluid will go downward, in the right limb the fluid will go upward. That is due to the existing pressure difference. Okay, so now we will identify this difference in terms of distance, that is x. We will convert that x into h. We will use that h with the area of this particular two points, that is area of cross section of pipe and area of cross section of vena contracta. And using the a1 a2 under root 2gh under root a1 square minus a2 square equation, we can find the q theoretical. Also we will simultaneously measure the q actual, and if you will take a ratio of these two, then you can eventually find CD, that is coefficient of discharge. This particular arrangement is used to measure the flow in any flow system, right?
Good morning students. So today we are going to discuss about the experimentation with Orifice meter. So let's understand the components first. So as you can see over here, this is the main component of the setup, that is Orifice meter. Here two pipes are attached, and in between these two pipes at this particular position a small orifice is inserted over here. This is the suction pipe, this is the delivery pipe, and this is the delivery controlling valve. This is the discharge tank. We have a lever operated valve over here. Then we have a reservoir tank over here. From the reservoir the water will be fetched with this green pipe through this motor, right? This is the bypass valve. You can control the flow of the water to the suction pipe through this bypass valve. Then again suction pipe is there, and one more thing, two pipes are attached over here to the U-tube manometer filled with mercury. One is attached to the main pipe cross section and the other is attached to the vena contracta after the orifice section. So these all are the components of our setup. Now to find out the CD, that is coefficient of discharge for this Orifice meter, the simple equation is CD is equal to Q actual by Q theoretical. Now first is Q actual. Q actual is discharge actual, so we can measure the actual discharge using this particular discharge tank. Here we have to find out length, width and height for the tank, right? And for the same height the time taken for filling the water, right? So these 3 and 4 readings will be taken, LBH and time, for the Q actual. So that will give us Q actual, that is volume divided by time in meter cube per second. And the second thing is what? Q theoretical. So Q theoretical can be found out using the theoretical equation, that is A1 A0 under root 2gh divided by under root a1 square minus a0 square, where a1 will be the area corresponding to the diameter of the main pipe or suction pipe, and a0 will be the area or cross section area corresponding to the vena contracta diameter. Right? Vena contracta is what you are very well aware, that is the minimum diameter of the jet through the flow. Right? Now that a1 and a2 we can find out, right? That is given in the manual, and the other thing is we have to find out h. So for h, that is manometric head, we will observe the reading of the U-tube manometer. So the difference between two limbs in the mercury, that will be observed as x, right? So we have to convert x into h. So for that we will use the equation h is equal to x into sh by s0 minus 1, where x is what? Difference between two mercury limbs, then sh is what? Specific gravity of heavy fluid. Here we have mercury as the heavy fluid, and s0 is what? Specific gravity of light fluid, that is water. sh for our case will be 13.6 and s0 for our case will be 1. Right? So all are sorted. Let's start the experiment. So the setup is on. Right? The water is flowing through this orifice meter. Right? So first of all, let's find out the Q actual, and for Q actual we know the length and width of this tank from the given manual. We will find out the height. Right? So for height we will arbitrarily take the interval of 10 centimeter. So right now what I will do, I will first of all close this lever operated valve, and then I will start the reading at 5 centimeter and I will stop at 15 centimeter. Right? So first of all, let me close the valve. Let us now we will start the reading at 5 centimeter depth. Start. Stop. So right, so time taken for 10 centimeter interval of height is 15.35 second. Now let's measure the difference between the two mercury columns. So as you can see over here, the difference is very simple. That is, over here in the left limb we have the reading of 7.7 centimeter, and on the right limb we have the reading of 13.5 centimeter. So this difference will be our x, 7.7 centimeter and 13.5 centimeter. Right? So to find out the CD of this orifice meter, what we have to do is, for Q actual we have to take the reading of LBH and time, and for Q theoretical we have to find out A1, A0, that will be given in the manual, and the value of H from the X. Right? So that's all.
So after experimental setup, now let's move forward to the calculation part. So here we have the given data. So list of given data is mentioned in the screen. D1 is the diameter of the pipe, that is 0.025 meter. D2 is the diameter of vena contracta, that is 0.015 meter. L is length of discharge tank, that is 0.4 meter. B is width of discharge tank, that is 0.2 meter. SH is specific gravity of mercury, that is 13.6, and S0 is specific gravity of water, that is 1. Now CD, we know that we want to find, that is Q actual by Q theoretical. First of all, for Q actual we need time and volume. So here you can see the list of measured data on the right side. That is capital H, that is height of water tank that we have arbitrarily taken, that is 10 centimeter equivalent to 0.1 meter, and time required to fill that amount of height is equal to 15.35 seconds. Now X is what? Difference in limbs of manometer, that is 0.058 meter. A1 and A2 is what? Cross section area corresponding to D1 and D2, that we can easily find out using pi by 4 d square. Right? So now Q actual is equal to what? Volume upon time. Volume of the tank is what? LBH divided by time. L we know, B we know, H we have measured, and time we have measured. So substitute the value, then you have the discharge as 0.000521 meter cube per second. Now let's move to the Q theoretical. So Q theoretical is equal to A1 A2 under root 2gh divided by under root A1 square minus A2 square. Right? So here H is equal to nothing but X into SH by S0 minus 1 is equal to X is known to us, that is 0.058, SH is 13.6, S0 is 1. So you can find out the H as 0.7308. So H you substitute over here in this equation, you can find the Q theoretical as 0.000716 meter cube per second. Now if we take the ratio of these two quantities, then we can have the discharge CB, that is equal to 0.73, right? So that is all. Thank you.